Hello. To begin, this is our capstone project for Management 590. So for this project, we've decided to continue using some of the flight data that we previously looked at in the past units for this course, and we've combined that, particularly the OpenSky API or the 2022 flight data, and we've combined that with the weather API data that we were able to find, as well as historical flight data to look at the weather patterns for 4 major airports: Chicago, Atlanta, JFK, and LAX. And we have combined that together to look at potentially coming up with some predictions for flight delays as real-time weather data comes in the future, and creating a machine learning model to predict for that.
To prepare the data for this project, we decided to use flight data, archived weather data, and real-time weather data. Previously in this course, we had labs that set up API calls through Cloud Functions to get flight data through OpenSky. We continued to use this for this project to keep getting active flight data. For the archived weather data, we pulled an entire year, 2022, of weather data for the 4 airports in our project from Meadowstat.net. And for the real-time weather data, we utilized the OpenWeatherMap API and set up similar cloud functions utilizing Python code to pull weather reports every 3 hours. When the reports were pulled, they were pulled as CSVs, and the act of writing it into the buckets triggered another cloud function to utilize Python code to write the data and append it to the tables in BigQuery.
This slide details some of our historic flight data that we used. Now we gathered data from 2022 to correspond with the flight data that we had from the Department of Transportation. We gathered the average daily precipitation, temperature, and other such factors that might contribute into certain weather conditions. And again, we did this for the 4 airports that we were looking into for this project, which is LAX, JFK, Chicago O'Hare, and Atlanta. And as we gather this data, we will eventually use this data as part of our applications for a prediction model, which can take a look at this past data, how it relates to the data within the average delays, as well as using it to then predict how current weather statistics might affect delays in the future.
We developed a logistic regression model using Google Cloud's AI platform to forecast flight delays at major U.S. airports. The model was trained on historical flight and weather data with the goal of predicting whether a flight would be delayed by more than the median arrival delay minutes. The metrics achieved from validation revealed some interesting aspects of the model's performance. With a recall of 1, the model successfully identified all instances of significant delays. However, the precision of 0.64 indicates that while the model captures all actual delays, it also generates a number of false positives, cases where a delay was predicted but none occurred. Given these results, the model is particularly effective in scenarios where it is crucial not to miss any delays, such as in proactive airport and airline management. However, the relatively low precision indicates that there is room for improvement, especially in reducing the number of false positives.
In this slide, we present real-time delay predictions generated by our flight delay prediction model, which utilizes BTS and weather data. The graphs below highlight the critical factors influencing these predictions. The first graph on the top right predicts the likelihood of delays. Here we see JFK has the largest probability at 70%, followed by ATL at 66%, ORD at 64%, and lastly LAX at 63%. The other 4 graphs on airport temperature, wind speed, cloud coverage, precipitation, and current airport conditions illustrate key environmental factors that significantly contribute to predicting flight delays. By integrating these variables, our system is able to provide accurate and timely delay predictions.